The triangle ABC is a pond in which the angle ABC is 50 degrees. So angle ABC is 50 degrees. So this angle here is 50 degrees. PQ is a plank placed across the pond and cuts the side BC at OR. This is point OR here. Q lies on the line AC. This is AC. This is Q. And the angle AQP is 15 degrees. So AQP is 15 degrees. If the length of POR is equal to the length of PB, so POR is equal to the length of PB, show that the length of AB is equal to the length of BC. So the length of AB is equal to the length of BC, i.e. that the pond is isosceles, so that the triangle ABC, or the pond, is an isosceles triangle. In all geometry questions of this nature, it is necessary to give an explanation for each step of your reasoning. Draw the diagram again, naming angles that are important in the deductions. So consider the triangle BPOR. So BPOR. As POR is equal to PB, so POR is equal to PB, by the isosceles triangle theorem, angle 1 is equal to 50 degrees. So we already know that POR is equal to PB. That's why we've got these two little lines drawn in to show equal length. So we already know that this triangle is isosceles. So if this angle is 50 degrees, then this angle, angle 1, that we've labelled ourselves as angle 1, is also 50 degrees. Then, by vertically opposite angles, angle 2 is also equal to 50 degrees. So we've labelled the angle that is opposite to angle 1 as angle 2, and since opposite angles are equal, angle 2 is also 50 degrees. So we've got 50 degrees, 50 degrees, and 50 degrees. So angle 1 is 50 degrees and angle 2 is 50 degrees because they are vertically opposite each other. And by the angle sum in a triangle, so we know the angles in a triangle add up to 180 degrees, angle 3 plus 50 degrees plus 15 degrees is 180 degrees. So angle 3 is going to be equal to 115 degrees because 180 minus 15 minus 50 is 115. So angle 3 is 115 degrees. So here's a triangle ORQC. Angle 2 we worked out to be 50 degrees. We were already given that this was 15 degrees, so 180, take away 50, take away 15, leaves us with 115 degrees. So the angle QCR is 115 degrees. Then, by a straight angle, so what that means is that angles on a straight line add up to 180 degrees. 115 plus angle 4 will give us 180 degrees. So 115 degrees and angle 4 lie in a straight line, and angles on a straight line add up to 180 degrees. So 180 minus 115 is 65 degrees. So angle 4 is 65 degrees. So we have a straight line. We work this out to be 115 degrees. So 180 take away 115 is 65 degrees. And by the angle sum in a triangle theorem, so the theorem that tells us that the angles in a triangle add up to 180 degrees, angle 5 plus 65 plus 50 should equal 180 degrees. So if we take the triangle ABC, we know that this angle is 50 degrees. We know that this angle is 65 degrees. So 180 take away 50 take away 65 will leave us with angle 5, which is going to be 65 degrees. So 180, take away 50, take away 65, leaves us with 65 degrees. And as angle 4 is equal to angle 5, so angle 4 is 65 degrees, angle 5 is 65 degrees, by the isosceles triangle theorem, the length of AB is equal to the length of BC. So the length of AB is equal to the length of BC. And thus, the pond is an isosceles triangle. So this might have seemed like a complicated question at first, but if you think about it like a puzzle, and there are pieces of the puzzle, and you might not necessarily know where to start, but just start somewhere. Try and identify the different angles. Draw into your diagram the different angles as you find them. See the way I built up my diagram, and I drew in all the angles that I found. And then eventually, you should come to what you're looking for. So it's a really good idea. Think of it like a puzzle and add in the pieces of the puzzle as you find them.